Why the reverse saturation current is more in germanium diode when compared to that of silicon diode? The answer is atomic model. Atomic number of silicon is 14, whereas atomic number of germanium is 32. In silicon atom, there are 14 protons present inside the nucleus and 14 electrons are present outside the nucleus in orbitals. Likewise, in germanium, as the atomic number is 32, 32 protons are present inside the nucleus and 32 electrons will be present outside the nucleus in orbitals. In silicon there are only 3 orbitals, whereas in germanium there are 4 orbitals. Nevertheless, in both the atoms, in the outermost orbital, there are only 4 valence electrons. That is, both have 4 valence electrons in their outermost shell. The difference lies in the distance between the outermost shell and the nucleus. If d1 is the distance between the centermost point of the nucleus and the valency shell in silicon atom, and d2 is the distance between the centermost point of nucleus and valency shell of germanium atom, clearly d2 is greater than d1 because it is in the 4th orbit, whereas valency shell is the 3rd orbit in silicon. As the distance from the valence 4 electrons from the nucleus is more in germanium atom, very less energy is enough to set an electron free from its valency shell. As the distance is more, the effect of nucleus on the valence electrons is less. Less energy is enough to remove an electron from the valency band, or to move an electron from valence band to conduction band, or to set an electron free from its valency shell conduction band as compared to that of silicon. Therefore, less energy is enough to remove one electron from the valence band of a germanium atom when compared to that of a silicon atom. So at a room temperature, that is due to thermal agitation, more number of electrons are present in the conduction band and hence more number of holes are present in the valence band for a germanium atom. The reverse saturation current in silicon diode is less than the germanium diode because the energy gap of silicon is more than that of the germanium. We can also state this as one of the reasons. If we see the comparison table among silicon and germanium, the atomic number of silicon is 14 whereas germanium is 32. Cut-in voltage in silicon is 0.7 volts, in germanium it is less. Reason is atomic model. Energy band gap in germanium is less. Reason is atomic model. Reverse saturation current in germanium is in microampere, whereas in silicon it is in nanoampere, and the reason is atomic model.